Hello and welcome back to my channel and to the ConQuiz series episode number 7, Concept Booster on Chemical Kinetics. Today we will be discussing MCQ, Understanding through MCQ, Part 1, and all questions are taken from IIT-JAM and NET previous year's papers, because one of our aim of this series is to help you to prepare for different types of exams, including your BSc Chemistry Honors, IIT-JAM, NET, here. So today let us start with MCQ part 1. First, let us start with some warm-up problems on unit, order, etc. The first problem goes like, for a reaction 2A plus B to 3Z, if the rate of consumption of A is given, the rate of formation of Z, that is 1. So as you see, that the reaction is 2A plus B, and that gives you 3Z, right? Now the rate of consumption of A, that is if you say RA, and from stoichiometry it is clear that RA is not equal to R of Z, right? But if I half here and 1/3 here, then of course they are equal. So now they become equal, right? So RZ, that is 1/3, is equal to 3 by 2 RA. RA is given with 3 by 2 into 2 into 10 to the power minus 4 units. So it gives you 2 allow 3 into 10 to the power. So let us see the options. So option is 2 4. Yes, the option is A. Okay. Let us go for the second problem. For a reaction of the type A plus B products, the unit of the rate constant is mole retained. So the overall order of the reaction is. So as you know that from the reactant situation A to B to product, the rate is K T to the power some n order is unknown, and K equal to then rate C to the power minus. Okay. Now rate is always M is inverse, and C is M to the power minus n. So it gives you M to the power 1 minus n is. So this is the general expression for rate constant. But here the unit of rate constant is given, that is what is given here, and that is mole per liter, that means M. So clearly 1 minus n, to equate the power here, n to the power 1 is there. So clearly 1 minus n 2, n equal to 0, n equal to 0. So it is the 0th order reaction. That means option A should be correct. Option A is correct. Okay. So let us go for the next problem. The unit of rate constant of a reaction is again same type of questions, that you know that M to the power minus 3. That means M to the power minus 3. So this is actually M to the power minus 3. So if you equate this power 1 minus n, and that is equal to minus 3. So n equal to 1 plus 3, that is 4. So let us see what are the options. 1, 2, 3, 4. So option D is there. I think that should be the answer. Yes, option D. Order n equal to 4. Okay. Next question. A to 2B plus C. So let me just write down first A to all our gas phase. So 2B plus C. So initially some pressure was there and nothing there, and after some time P0 minus X and it gives 2X. So if you are interested to calculate the pressure total PT, and that would be P0 minus X plus 2X plus X, that means P0 plus 2X. So P0 plus. So from here you can evaluate X actually. X is PT total minus P0 by 2. Now why X is needed and how it's needed? Actually the equation that I have to finally use that is R equal to 1 by P ln P0 by P0 X. So here X is here dot. So you can evaluate P0 minus X from here, and that would be P0 minus PT minus P0 by 2. That means 2 P0 minus PT plus P0 by. So it should be 3 P0 minus PT divided by. So you just put it here. So you should get 1 by P ln P0 by 3 P0 minus PT, and this 2 comes here. So it is 2. So now we can check which option is correct. I think it is TP0, but I think it will be B. So it is B. Okay. Let us go for the next. The rate of decomposition of a gas is 10 unit when 10% is there. So when 10% is reacted, that means in terms of fraction, it is 0.9 if you call it 1, 0.9, and for the second case R2, when 40% is reacted, that means 60% is remaining, so it is 0.6. R1 and R2, two different concentrations, but the corresponding rate R1 and R2 that are given as 10 and 5. Okay. Now what relation we use, we can go in the order. So we can start from the general expression that R is proportional to small r is rate and capital R is the concentration. So if you say R2 by R1, two different R2 by R1, and that should be equal to R1 by R2, R2 by R1, so 0.6 by 0.9, 0.6 by 0.9 whole to the power. Okay. Now R2 is given as 5. So 5 by 10. So 5 by 10. That means half. Half. That means 2 to the power minus. And it is something 1 by 1.5 to the power. So if we just take log of both sides, and finally we get the order, and that would come as 1.7971. Okay. Let us see the options. Yeah, so 1.71, I have checked it by calculator. So this is the correct option. The option should be B. Okay. Let us go for the next problem. the rates of a reaction are R1 and R2, capital R this time they are using, and concentration C1 and C2 of a reactant respectively. The order of reaction N at constant temperature. Then with respect to that reactant is given by order is given by which equation. So again you can start from the same equation, same formula, that R is proportional to P. So R is proportional to concentration to the power N, proportional to constant there. But if you consider two reactions, then R you can say R1 by R2, R1 by R2, that would be equal to C1 by C2 whole to the power. So obviously you have to take the log. So log or ln you can say R1 by R2, and that would give you N log C1 by, right. So obviously N is the left hand side, which you can rearrange to be log R1 minus log R2, and whole divided by the right hand side log C1 by C2. That means again you can rearrange log C1. So I think now you can check the option log R1 minus log R2 log C1. So I think it should be option A. Yeah, option A. Thank you. For the next slide, okay, a gas phase decomposition of A at 1000 Kelvin follows two paths. At the same time, A goes to B plus C and A goes to P plus C. Two different paths having of course different rate constants 3 and 5. So the maximum theoretical percentage yield of P at 1000 Kelvin is. So done it. The answer is A to start with. Let us check the A to B plus C and A to P plus C. Okay. Now rate K to A overall rate. If you say not overall rate of P, so dPdt is actually K to A. But since this mechanism how it shows that A can be given as the phosphorus part. Again K1 and K2 both are important for decomposition of A. So A is A0 e to the power minus K1 plus K2, right. Then what will you will integrate. So dP is K2A constant e to the power minus K1 plus K2T, and if you integrate some minus K1 plus K2 will come the denominator, and this will be here, and if you put the limit, actually you will get minus 1 for this part. Okay. So so P infinity, why I am putting infinity? Because we are putting the time limit infinite and it's a first order reactor, so it only gets completed after infinite time. So maximum yield that you can expect after infinite time. So what we can do that this, if this value is minus 1, so minus 1 into minus 1 plus 1. So it is basically K2 A0 by K1 plus, right. So percentage yield is the P infinity product divided by the initial, that is A0 into 100, but P infinity is this one, okay, just minus becomes plus, right. So A0 cancel out, this A0 and this A0 cancel out, so it gives you K2 by K1 plus K2 into 100. So K2 is 5 units, K1 is 3 units, so 5 by 5 plus 3 is 100. Okay, so that is the option A. It is the right. So let us check. Yeah, option A is already okay. Okay. So after the warm-up problems on order, unit, etc., let us go for the plots. Different types of plots that we have discussed in the last session in details. So reaction A to products follows first order. if A represents the concentration of reactant at time t, the incorrect variation is shown in incorrect. So you have to pick up the correct ones and then automatically you will get the incorrect. So as you know from first order kinetics that A is A0 into e to the power minus. So this equation directly indicates that A varies exponentially with t. So this figure A is that. Okay. Now dA. So rate is minus dA. So this is actually rate. This is rate, and rate for first order reaction is K A to the power 1. So it is a straight line, of course, but the slope is K. But here in this figure, the slope is negative. So of course it is the wrong. So you have got the incorrect one, but still you can further check the other two options. Minus dA dt, that is rate. Again this is rate, and that rate with time. So rate is K A to the power 1, but that A is from here. A is A0 given constant term greater than minus K. So finally what you see that K exponentially decays with time. So this is the figure for that. So figure C is alright, and if you take log here, so log A is log A0 minus KT. So of course this is straight line with negative slope minus K. So you can either go for, what are the options, let us check, 0, 1, 1, 0, 0, 2 and 2, 0. So either you can one by one you can go for trial and error kind of thing, but if you want to get it directly the answer, then you have to start that rate equal to minus dr dt, of course dr is the concentration, capital R, and that should be equal to some k c to the power. Okay. So if you integrate, I mean dr by, oh this is R, so you can write dr by r to the power n equal to k dt minus k dt. So and now you can integrate 0 to t and r to r, then what you will get, that minus n plus 1 r to the power, if you put the limit then you will get minus n plus 1 equal to minus k. So that is your general expression. Now if you, from this expression, if you want to have r, simply r, that means here you have to put something so that r to the power 1 comes, that means n must be 0, and on your right t is there, so that is exactly what you want to plot against t, against t. So the first case n equal to 0, that only gives you r versus t, right, and also you can check that the slope is 0. And again on same logic, if you want to get on your left 1 by r, that means r to the power minus 1, that means minus n plus 1, this power should be equal to minus, right. So that means n equal to, so n equal to 0, the first one, and equal to 2, the second one, that should be option, that means option C should be the correct. Let us check, and C is the correct. Okay. Well, this is a bit tricky question. For the reaction shown in scheme 1, the concentration profiles of different species are defined. Okay, so here from R it goes to different parts S and Q, and then S and Q gives P finally. So the variation of concentration of all these P, Q, R, S are given in this figure, and now along with the rate constants for every step, so you have to check one by one the option K2 greater than K4. So K2 is involved here, that means Q, and K4 also involves Q. So you have to focus on the concentration of Q. Now this means this figure. So obviously from the figure, the rate of formation, this side is very fast compared to this side. Right? So that means formation means K2 is involved. So K2 is faster than K4, greater than. So this option A is correct. Now K3, option B, K3 and K1. So K3 is involved here and K1. That means you have to focus on the curve of S. That means this S. And here we see that the formation rate is slower than the decay rate. Okay. That means formation rate means K1. So K1 is less than K3. So option B is exactly that. So option B is also correct. K2, option C, K2 greater than K1. So K2 is involved here and K1 here. So from the figure, that means you have to be focused on both Q and S. Q and S. So if you look at the figure, that at any point of time, the concentration of Q is greater than concentration. That means concentration of Q is greater, that means K2 is greater. So K2 is greater than K1, that is also correct. So it seems to be that all are correct. No, because if C is correct, then D cannot be correct because it is K1 equals to K. So D is the right. So here are more than one answers are correct, and the answers are A, B, and C. All are correct. Okay. The rate constant of a second order reaction to A to Z is K. If the initial concentration of A is small a and ZT is X, then a linear function of T with the slope of Ka is. So we have done a lot of problems like this. So I am leaving it this problem as an exercise with of course the answer. These are the options, and we just record that the option is correct option is C. So a plot of X by A minus X against T would give you a straight line with slope A as in the question. For a second order reaction A to P, the straight line among the following plot is. So what are the options? These are the options. And second order reaction, so you can start from your experience that or from my memory that the second order reaction is very simple. We have discussed in earlier session details. So 1 by AT is given as 1 by A0 plus A. So this is the typical second order kinetics equation, integrated rate law. So 1 by AT versus T, that will be the plot, right? So 1 by, so which option is correct? 1 by A versus that. So I think option B should be correct. Option B is correct. Okay. Same way, in a kinetic study of a chemical reaction, slopes are drawn at different times in the plot of concentration of reactants versus time. The magnitude of slopes with increase of time. Okay, so here it talks about rate. Slopes are drawn at different times. So rate for a reaction A to P, rate is, you know that it is what? It is minus dA dt. Okay, dA. So this is the rate defined in that way. But again, minus dA dt is nothing but it's a slope of on a plot of A versus P, A versus P, right? And that is given by, so you can call this magnitude of slope. This is a slope, and that is given by for a nth order reaction A to the power. Now, if provided that n is greater than 0, that means n is not negative, then with time C of course decreases. So if C decreases, then Kc to the power n decreases, but n greater than 0. So the slope, magnitude of slope, that also would decrease. So this is the correct option. Option C is the correct answer. Right. Next on half-life. Okay. So that is the last part of our session, half-life. So let us have a quick review on half-life for the typical n equal to 0, 1 and 2 for the reaction A arrow P. So T half is A0 by 2K. T half that is for first one is for zeroth order reaction. The second one is for half order half or 1. T half is ln 2 by k, and the third one is for n equal to 2, and that is T half is 1 by k into. So you see that here A0 is the numerator, here A0 is the denominator, and here no A0 is there. And in general, T half is given by this, and that means T half is proportional to a to the power 1 minus. If you forget about the other values, so it is proportional to a to the power 1 minus n. And you can get back that a general expression would give you T half for n equal to 2, and for n equal to 0 it would give you back the first equation, except this one, the middle one, that would not be obtained because this equation is not valid for n equal to 1, and this is for n equal to 2. So there is no problem with that. So with this much we can go ahead with the first problem. The half-life of chemical reaction in product. The initial concentration of reactants 0.1 and 0.4. Okay. So and the time half-life times are also given. So let us start with the expression just in the earlier slide I have discussed, that T half is proportional to A0 to the power 1. So this is your starting equation. Okay. And now you can think of that. Okay, let us suppose that T2 and T1 are the two T halves, T2 and T1. So that would be equal to A2 or you can say A1 by A2 to the power. Okay, this becomes now n minus. Not okay. Now A1 all are given. The T2 and T1 they are given as 50 by 200. So 50 by 200. That means 1 by 4. And here A1 by A2 is 0.1 by 0.4 to the power n. That means 1 by 4 to the power n. 1 by 4 to the power n. So 1 by 4 to the power 1 is equal to 1 by 4 to the power n minus 1. That indicates or implies that 1 is n minus 1 or n equal to. So the answer is n equal to 2. Second order. Okay. So let us check C. So option C is n equal to 2. The kinetics of the reaction is in liquid medium was measured independently for 3 different initial conditions. 3 different conditions. But the half-life of the reaction was found to be same, 4.5 hours for all these. So the order of the reaction. So of course we will not evaluate anything for this problem, because if you remember that, as I have shown in the review part, the T half is not a function of A0, not a function of A0 for order n. So of course the problem corresponds to order. Is option B. The right. Okay. The next one is for zero order reaction, half-life depends on the initial concentration of the reactant. As so again, that's from review that we know that T half for zero order reaction is T half is proportional to A. Okay. So that means this is for n equal to 0. So the answer is 0. That means C0 to the power 0. The question is for zero order reaction. So order is given. Okay. The half-life depends on the initial concentration. So it's just half-life is A0 0. That means A option. So option is that. Okay. The next one, again we will take help from the review part. The rate constant for a base catalyzed ester hydrolysis is this. Half-life in second would be closest to where concentration, initial concentration is given. So of course, base capitalized hydrolysis is a second order reaction. So we will be using the our known expression that T half is equal to 1 by K A 0. That is the value. So 1 by 0.2, the data are given already. K is this unit. I am not writing it anymore, and A0 is 0.05. So that means it gives you 100 seconds. So let me take the answer. So this is 1 second. So option B is the right answer. Next question. The half-life of a reaction is inversely proportional to the square of the concentration of the reaction, the order of the reaction. So this time order is unknown and you have to find. So you have to start with the general expression. Okay, let me check the option. These are the options. So you have to start the general expression that T half is proportional to A0 to the power 1 minus 10. Okay, 1. And the question gives you that the T half is proportional to the power square of the concentration reciprocal, inversely proportional. That means A0 to the power minus. That means the power 1 minus n and minus 2 are same. So 1 minus n equal to minus 2, and that means n is 2. So it's a third order reaction, and the option B is n equal to 3. So the right option should be option B. Okay. Next question, it goes like half-life of a third order reaction Tc2P would be what of the options are there. So it is again going to be a straightforward application of the general formula that we are using in last few problems, that T half equal to 2 to the power n, but this time proportional is not enough. You have to remember the whole expression, 2 to the power n minus 1. I am just writing, please bear with me, and divided by n minus 1, and then 1 by k a0 to the power n minus 1. So this is the, now put n equal to 3 here. So you can easily check that the answer would come as 3 by 2k square. 3 by 2k a square. So if you check the option 3 by 2k a square, that means A is correct one. Let us check option A is the correct answer. Okay. Next question. Reaction between A and B are carried out with different initial concentrations and the corresponding half-life times are measured. The data are listed in the table. So very typical problem. Different entries are there. The question is that the rate can be expressed as this. That means you have to identify that separately the order with respect to A and order with respect to B. So if you check that NT1 and NT2, concentration of A remains the same, but B doubles and T half remains the same. So B changes and T half remains the same. It is possible if the order is first order for with respect to B. So we get n equal to 1 for B. Okay. Now you check entry 1, 3 and 4. Here the B concentrations are the same, but A doubles, and as a result the half line becomes half. That means inverse. Here it is double and here it is half. So inversely proportional, that means indicates or implies second. So n. So that means rate should be proportional to A to the power 2 and B to the power 1. That means A square. So I think option C should be the right option, and it is option C. Okay. So thanks for watching. Our next video, session 8, that will be coming soon. and that would be on Chemical Kinetics Part 5. We'll be continuing actually understanding through MCQ Part 2 because a few things are left, Arrhenius equation, mechanism, etc. And the questions would be as usual be taken from IIT-JAM and their previous papers. So please keep on watching, do subscribe, encourage your friends to subscribe, to watch, and encourage their friends to subscribe and to watch. And please come back with comments, the suggestion, so that I can improve my video quality of presentation. I can start much better. Thank you very much.